Good morning, students. Today we are going to start Unit 4, that is Centroid as well as moment of inertia. So the same thing I write on the board. So centroid and moment of inertia, it is containing two parts. So one part is centroid, another part is moment of inertia. So first we deal with the centroid. So we discuss what are the important points in centroid and how we go to the problems. So then we discuss about what is called as moment of inertia. So in the examination, you will have one question on centroid and one question on moment of inertia. Both chapters are connected together, but they are separate. So you have to prepare for both. So now before first we start, what about the centroid first? So here we refer the word centroid with respect to 2 points. What is called as the same thing, we say what is called as center of gravity, and second what is called as centroid. So then what is the difference between center of gravity and centroid? Both words are same, but what is the difference between center of gravity and centroid that I mentioned here? So here I am showing you a duster. So duster, it is having a dimension in 3 directions, length, breadth as well as height. So it is called as 3-dimensional figure. So the entire weight or mass of the body will be acting through exactly at the center of gravity of the duster. So we say when we use the word center of gravity, we refer to the solid figures. Solid means it is having dimension 3 directions. Okay. So then, what is the difference between center of gravity and centroid? As I mentioned just now, center of gravity we refer to the 3-dimensional figure, whereas centroid we refer to only 2-dimensional figure. What is 2-dimensional? Here I take a file. So here it is having length as well as breadth. Thickness is very small. Okay, only 2 dimensions. Okay, the center of gravity of plane figures, it is called as centroid. For example, I take a circular plate, I take a triangular plate, I take a rectangular plate, I take a square plate. So the center of gravity of the plane figures is called as centroid. So then, as I just mentioned you, center of gravity we refer to the solid figures, centroid we refer to the plane figures. Okay. So then I'll give you some table now. The table is very important as far as the problem is concerned. So just I write the heading of this one and I draw some figures here. So those are very important. Centroid of standard plane figures. First one I write a square. I draw the figure here. I draw the square of dimension length L. I have shown the origin, x-axis, and this is y-axis. What you must remember here is, whenever we mention centroid, always we mention with reference to axis, 2 axis, x-axis, y-axis. So here, this is the point where you will have a centroid G. So the same, I write the value here, x bar, y bar. that is L by 2 and L by 2. Okay, centroid exactly at this point. Okay, so here we have got some derivation. The derivation will do it later, but now you have to remember this table because that table will be very helpful when I come to the problems there. So now it is having square is having a length L. X bar is exactly x bar we measure parallel to x axis, y bar we measure parallel to y axis. So then, so this is y bar, x bar is L by 2 and y bar is L by 2. I go to second figure. So I written here rectangle as I just mentioned now. I am showing origin, I am showing x-axis and y-axis. As I told you, whenever we mention any figure, we have to refer axis, x-axis as y-axis. Otherwise, the further things will be complicated. You must know with reference to what axis we are doing now, x-axis and y-axis. So this is having the dimension b and d. The centroid will exact this point, x bar parallel to x-axis, half of this b by 2, y bar parallel to y-axis, half of this that is d by 2. So these values you must remember. So then I come to the third one. Triangle. So now what I am mentioning here is a right angle triangle. Okay. So in the right angle triangle I am taking the base as b and height as h. I am marking the centroid. So x bar comma y bar, I am writing here v by 3 and h by 3. So you must remember one important point. What is the important point here is whenever I mention a right angle triangle, okay, so this is called as apex or a tip. This is called apex or tip. Okay, so this is called as the base. So from the base, if you measure x bar, exactly one third of this b by 3. Similarly, when you measure here y bar, that is exactly one third of height h by 3. Suppose the same centroid. Suppose if you measure from this point, okay, parallel to x-axis, total is b. So from here it is one third of b. From here it is 2/3 of b. So that you must remember because when I come to the problems there, you may have to measure from either from that direction or from this direction. Similarly, if you measure vertically, okay, so this is y bar, that is exactly you are measuring from the base, that is y bar is one third of h. If you measure from apex or a tip, this value will be 2/3 of h. So this is a very, very important point, especially with the triangle, because now I am mentioning with origin O. Okay, you may get a triangle in any shape. So you must have to measure whether you are measuring the centroid from the apex or from the base. From the apex or the tip, I told 2/3. From the base, it is 1/3. For example, I will draw another triangle here. Let us draw a triangle. So this is 90 degrees. Suppose this is 9 meter. So this is 6 meter. Okay. I have to mark a centroid. Suppose, so this centroid will be at this point. I told you, if you measure here, okay, this is 9 meter. So this will be 3 meter. 3 meter, 1/3 of 9. If you measure from here, this will be 6 meter. It is 2/3 of 9. 2/3 of 9. That will be 6 meter. Similarly, if you measure from here, that is 1/3 of 6. So 1/3 of 6 will be 2 meter. This 2 meter. If you measure from the apex, it is 2/3 of 6. That is 4 meter. So this point you must remember correctly. Otherwise, what happens here is, when I come to the problem there, if you don't remember the points, problem will go wrong. So now, what I will do, I will draw a triangle of a different shape. So from that, you will be able to understand how to mark, because those things we come across when I come to the problem there. So what I will do, I will draw a triangle of different shape. Suppose I will draw another triangle here, like this. Okay. So this is 3 meter. So this is 12 meter. So I have to mark a centroid. So how to mark a centroid? Look here. First of all, you must see where 9 degrees. So this is 90 degrees. First you must have to see where 90 degrees. So this is called as tip or apex. This is also called tip or apex. I told you, from the apex if you measure 2/3, from here it is 1/3. If you measure from tip 2/3, from here it is 1/3. This is 12 meter. Centroid will be at this point. If you measure from here, apex 2/3 of 12, that is 8 meter. If you measure from here, 1/3 of 12, that is 4 meter. So similarly, if you measure vertically like this, 2/3 of 3, that is 2 meter. If you measure from here, 1/3 of 3, that is 1 meter. So this point you must have to remember, whether you measure from apex or whether you measure from the base, you must know where to take 2/3, where to take 1/3, because when I come to the problem there, we may have to measure sometimes from the apex, some from the base. You must have to mark the centroid correctly, otherwise problem will go wrong. Now what I will do, I will take another example of a same triangle. 90 degrees, let us assume this is 6 meter, let us assume this is 18 meter. Okay. So I told you, 90 degrees is very, very important. This is called as apex, also called as apex. I will mark centroid here. Okay. I told you, if you measure like this, from the apex, 2/3 of 18. So 2/3 of 18 will be 6. So this is 12 meters. If you measure from here, 1/3 of 18. So this will be 6 meters. Okay. So 1/3 of 18. Similarly, if you measure like this, apex, 2/3 of 6, 4 meter, 1/3 of 6, that will be 2 meter. So you must have to, they may give a triangle of any shape. Okay. What you must remember here is where the 90 degrees is there, where is the apex is there, and where is the 90 degrees right angle triangle is there. So this plays a very, very important role when I come to my further discussion in the problems. You must remember the right angle triangle, where is the apex and where is the base, and you have to mark the centroid correctly. So next I come to semicircle. Semicircle. Okay, I will draw a semicircle here. This is semicircle what I drawn here. So semicircle exactly half of the circle. Okay, if this is center point, from where the semicircle is drawn. If you complete here, so this will be the circle. Okay, but I am not drawing circle. So we are discussing only about the semicircle. So now this is the origin point. The centroid. Centroid will be exactly at this point. Okay, so I mark here. This is x bar. That is equal to exactly radius. Center. This is r. This is equal to r. So this is y bar. This is 4r upon 3 pi. Okay. So now how it is 4r upon 3 pi? I told you when we derive the equation. And derive the equation at that time you will understand the equation for y bar. So now for the timing you must remember whatever the table I am giving. So once I discuss the table, once you remember those values, we come to the problems. What you must remember is, so this is the origin point. So this is the center point from where the semicircle is drawn. Parallel to x-axis, x bar r. Parallel to y-axis, this is y bar. Y bar is 4r upon 3 pi. So that is the derived equation. Now what I will do here is, I will draw some different shapes of semicircle. From that you will be able to understand how we are how we go ahead with this further. For example, I told you when you measure from this point, so this is y bar, that is 4r upon 3 pi. So say what I will do, I will draw a semicircle in a different shape. Different shape means different side. First, for example, I will draw a semicircle like this. Like this. So where is centroid? Okay. I told you this is center point from where the semicircle is drawn. Draw a line from this here. From this point you have to mark. So this is 4r upon 3 pi. Okay. Now I am not discussing about x bar and y bar. Only you must remember first where is the centroid. Okay. When I expand y bar I come later. Okay. So you must. I suppose if you get a shape like this. From this point, centroid, exactly 4r upon 3 pi. From this point, 4r upon 3 pi. First, suppose I will draw a semicircle of this shape. You make it any shape. Suppose I told you, the center point from semicircle is drawn like this. You have to mark a point. Centroid will be at this point. This value, this is 4r upon 3 pi. This is very, very important. Okay, 4r upon 3 pi. Suppose, same now, what I will do, I will draw a semicircle like this. Okay, I told the center point from which semicircle is drawn, draw a line, mark here, this is the centroid. From this point, this is 4r upon 3 pi. So this you must remember correct. Why? Because I told you, when I come to the problems, so you may get a semicircle in any shape. Any shape is either right side, left side, top or bottom. So at that time, this value is very, very important. Okay, if it is like this is 4r from this point. Like this, from this point 4r upon 3 pi. If you draw a semicircle from this point, 4r upon 3 pi. So this was the table I am giving, right from square, rectangle, triangle, semicircle. So all those equations or the values you must have to remember. What I will do next, I will come to the next one, what is called as the quarter circle. So quarter circle means exactly 1/4 of a circle. Okay, I will draw the figure here. This is quarter circle. If you complete a circle will be like this. But I am drawing only 1/4. That is quarter circle. 1/4 of a circle. So then what I will do, I will write x-axis, I will write y-axis. This is the origin point. I told you always we express centroid with respect to x and y-axis because that is the way how we do this. So then what I will do, I told you where we mark centroid. So once again here The radius is equal to r. So this is the point from where this is drawn. The radius is r. So this is the centroid. I mark here. So this is x bar and this is y bar. Okay. So then if I mark here bar comma y bar. Four r upon 3 pi, y bar also 4 r upon 3 pi. So now here I told you. So this is the derived equation. So you must remember only these values. If you remember these values, so then further equations, whatever that we go to the problems, that will be more easy. Okay, now as I drawn the different shape for the semicircle, similarly if I draw similar shape for quarter circle, for example, suppose I will draw a quarter circle like this. Let us assume I will draw a quarter circle like this. Then I have to mark a centroid. Where to mark centroid? I told you this is the point from where the quarter circle is drawn. From this point, mark a point. This is G. Okay. Parallel to x-axis 4 r upon 3 pi. Parallel to y-axis 4 r upon. This is x bar. Similarly, this is 4 r upon 3 pi and this is 4 r upon 3 pi. Suppose if I draw a quarter circle like this. Okay. I told you, you may get in any shape. When you get a quarter circle like this, from this point, from where the quarter circle is drawn, mark a point here. Okay, this is 4 r upon 3 pi and this is 4 r upon 3 pi. This is very, very important. Both are 4 r upon 3 pi, 4 r upon 3 pi. So I told you, this is the derived equation. So this equation you must have to remember. So how it is 4 r upon 3 pi? When I come to the problems, at that time you will be able to understand how it is 4 r upon 3 pi. So now whatever the table had given you, that is the centroid of the standard plane figures, that is had given you square, rectangle, triangle, semicircle as well as quarter circle. Okay. So those points you must remember. So now I have to remember this because I told you when I come to the problems there, we get a combination of triangle, semicircle, quarter circle. At that time, these values are going to help you a lot. Okay. So now next I come to another important equation. Okay. I draw the heading on the board. I write the heading on the board. Draw one derivation. I write on figure here. Centroid of a flat plate. Centroid of a flat plate. So there is a small derivation. So this derivation is going to help when I come to the problem there. So first of all, I will draw the figure there. Once I draw the figure, so you will be able to understand what is the meaning of the derivation and why we go ahead with this. Okay. I draw the figure here. So now I am come to another important aspect, centroid of a flat plate. So what is the meaning of this and why we are doing this? I told you, we are deriving a small equation here. So that equation is going to help when I come to problems there. So now what I am taking a flat plate, okay, that is there in the xy plane. Z axis is perpendicular to xy plane. Okay, so now the plate is lying in the xy plane and z axis is perpendicular to xy axis both. So then total weight of this plate, that is W acting exactly at the centroid. So if you measure parallel to x axis, that is x bar, parallel to y axis, that is y bar. So now what I am marking here is I have to get and what is an equation for x bar as well as y bar. Okay, because so that is a general equation, so which is going to help when I come to the problem there. So that is why I am considering a general plate there, which is there in the xy plane. So T is the thickness of the plate. T is very, very small. Okay. So now what I will do, total weight of the plate is acting exactly at the centroid G. Okay. So now you have already learned in the previous chapters what is called the Vinod theorem. Okay. So Vinod theorem says moment of resultant is equal to the sum of the moments of the individual forces about the same axis or same point. Now how I apply the Vinod theorem here? W is the total weight, that is the resultant. The same plate, I divide this into a number of small parts. This one plate, small, I have divided it into this one. This I write as W1. This weight I write as W2. For example, if I draw the figure here of W1. So this is P. This is W1. Okay. If I remove this and I draw the figure here, there is only small component of this, that is W1. Similarly, if you take another one as W2. So now what I will do, I write this axis distance W1 x1 from W2, the value is x2. They are all perpendicular. Now what I will do, I am applying what is called as Vinod theorem. Okay, I told you. What is the Vinod theorem? Moment of resultant about any axis or about any point is equal to the sum of the moments of the individual forces about the same point. So now what are the individual forces? W1, W2, W3, W4, like that. So now total weight is W. Now if I add small W1, W2, W3, so on, that is equal to total weight W. So now what I will do, applying the Vinod theorem, I take moment of this weight about y-axis, that is, this is the force, perpendicular distance is x bar, right here, moment of resultant for any axis, that is the r into x bar is the perpendicular distance, that is equal to moments of the individual forces about the same point. Individual forces are W1, perpendicular distance is x1, so this is W1, perpendicular distance is x1, W2, perpendicular distance is x2, so right here W1 into x1 plus W2 into x2, so on, like this. Okay. So now if I write the same value x bar, this W I take it on this side, so W1 into x1 plus W2 into x2, so on, that upon capital W. Same capital W I write like this. So W1 into x1 plus W2 into x2, so on, that divided by, this is W1 plus W2, so on, because total weight W right here, W1 plus W2, W. So if you add everything, you are going to get the total weight W. So then this is equation for x bar. So now similarly you will get an equation for y bar. Now I write one more point, W1 x1, but when I come to the problems there, okay, we assume the density of the material as the rho, thickness already given T. After solving this with the same and this area, small area, take this as A1, W2 is A2, like that. So after simplifying this, how this equation we are going to get? Right here. So A1 into x1 plus A2 into x2, so on, divided by A1 plus A2, so on. Same equation, both of them. How I write here? see, we have drawn density. Density is equal to weight upon volume. Okay. So after simplifying this, okay, we are going to get this one. So volume we write area into volume, we write area into height. Okay. So after this one, after solving this, after simplifying, we are going to get the equation like this: a1x1 plus a2x2. So this equation is very, very important. That means x bar is equal to a1x1 plus a2x2 so on over a1 plus a2. So this is one equation. Similarly, I get another equation for y bar. Same way. Okay. Now, what I will do here is I write w1, the distance x1. So similarly, parallel to y-axis. So this is y1. Similarly, parallel to y-axis, this is y2. Same thing, I write an equation for y bar. How I get here? On the same similar basis, I get an equation for y bar. I write that. Like this. So now, one equation for x bar, another equation for y bar. X bar is equal to a1 x1 plus a2 x2 so on upon a1 plus a2. So y bar is equal to a1 y1 plus a2 y2 so on a1 plus a2 so on. So this both equations, that is equation for x bar and equation for y bar, both equations are very, very important. Okay. Why they are important? Because as I told you many times, when I come to the problems there, so it will be a combination of circle, semicircle, quarter circle, triangle. So at that time, we are dividing the entire area into different parts. Then we have to write this equation for x bar as well as y bar. I told you many times you have to find out when the problem is given, you have to find out both x bar as well as y bar. So to get x bar and y bar, you must have to remember this value. Okay. So this detailed derivation. Okay, I had written almost all the steps. I have already given you the notes. Yes, you can go through that notes. In between the steps you can go through, but those steps are not important. But what is our final equation? Final equation is, this equation is very, very important. So you go through that, whatever the doubts there, you come and discuss it. So now, so this is the general idea I had given you about the centroid and how we get an equation. So next we come to another important aspect. Okay, I just write on the board. Axis of symmetry. Okay. So far whatever the discussion I have done, that is centroid of a flat plate, and so we come to another important topic, because this also plays a very, very important when I discuss about the centroid problems of centroid. Now what is the meaning of symmetry? I will draw some figures here. From that figure I will be making clear what is the meaning of axial symmetry. Here I have drawn 3 figures, figure 1, figure 2 and figure 3 with respect to axial symmetry, because I will tell you how this axial symmetry will play an important role. First I have drawn T section. Okay. Let us assume this dimension as 10 centimeter. Okay, exactly at 5 centimeter I mark a point. Suppose measuring 2 centimeter, exactly 1 centimeter mark a line. I will draw a line exactly at the center. Okay. When I draw a line here, okay, whatever the figure on the left side, same figure getting on the right side along with the dimension. If it is measuring 5 centimeter, this also measure 5 centimeter. Cannot measure more than that. Similarly, whatever the, if it is measuring 1 centimeter, it has measure 1 centimeter. Whatever the figure on the left side, same figure you get on the right side along with all dimensions. So then we say this figure is symmetrical about vertical y-axis. I tell you how this plays an important role. I'm gonna come to second figure. I draw a line here, exact at the center. Whatever the figure on the top, same figure you're getting on the bottom. Okay. I say this figure is symmetrical about horizontal x-x axis. This figure is symmetrical about vertical y-y axis. Then third figure, it is symmetrical about both axes. If I draw x-axis here and if I draw y-axis here, okay. So now, how this plays an important role? I told you, we are discussing what is called axis of symmetry. First one, it is symmetrical over y-axis. Second one is symmetrical over x-axis. Third one is symmetrical over both axes. These two are complete. Now, when the given figure is symmetrical over y-axis, whatever the figure on the left side, same figure on the right side, centroid is going to lie on this axis. That means centroid, this side, it may come here, may come here, it may come here, but it will not come here, here, here. This is very, very important point, because there is a small derivation how the centroid is going to lie on symmetry, but the derivation is not important. What you must remember, where the centroid lies. How the axial symmetry will play an important role. Then this is symmetrical y-axis, centroid is going to lie on this axis. Second figure, it is symmetrical about x-axis. Then centroid is going to lie on this axis. That means it may come here, it may come here, and sometimes it comes here also. It will not never come here, never come here, 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 here. It will not come. It will come on axial symmetry only. Centroid is going to lie on axial symmetry. This figure is symmetrical x-axis, because if I draw a line here, it is not symmetrical about y-axis, symmetrical about x-axis. Similarly, this figure, if I draw a line here, okay, figure on the top, figure at the bottom, not same. It is not symmetrical about x-axis, symmetrical about y-axis. This figure is symmetrical about x-axis. Okay. So this is called axial symmetry. On this point, centroid is going to lie. Third figure. If I draw x-axis here, whatever the figure on the top, same figure on the bottom. If you draw y-axis here, whatever figure on the left side, same figure on the right side. Then where centroid lies? Where the centroid? So where these two axes will meet, this point, centroid is going to lie. This is very, very, very important. So now, when I come to the problems here, okay, when I come to the further problems, so what you must remember is centroid. Okay, so first of all, you must have to detect where whether the given figure is symmetrical y-axis or x-axis or symmetrical both axes. Okay, so what you must remember is the given figure. If it is symmetrical to y-axis, so this is y-axis here. Centroid is going to lie on this axis. Okay. If the given figure is symmetrical about x-axis, centroid is going to lie on this axis. Okay. Centroid will never lie here, never lie here. I told you there is small derivation. So derivation will do it later. That is not required. So you must remember now what is the meaning of axial symmetry. So this is symmetrical about y-axis, symmetrical about x-axis. This given figure is symmetrical about both axes. Okay. When a given figure is symmetrical both axes, where centroid lies? Centroid is going to lie where two axes will intersect at this point. So now, these whatever the discussion have done, that means what is meaning of centroid, what is the meaning of center of gravity. So then I had given you the chart of the different standard plane figures, that is square, rectangle, triangle, semicircle, quarter circle, those whatever the points I have discussed, that is where you will have x bar, where you will have y bar. So whether it is a triangle, when it is a rectangle, how you are going to find the x bar and y bar. When it is a square, how you are going to find the x bar and y bar. It is a triangle, you must remember where the apex is there. From the apex it is 2/3 of this one. From the base it is 1/3. So whatever the points I have discussed and whatever the table I had given, table is very, very important. You must have to remember that. Similarly, when I discussed about the semicircle, semicircle means I had told you so exactly half of the circle. So you have to first of all you have to locate where the center of a semicircle, then draw a line. Okay, at the vertical line or horizontal line, that point will be the center will be at the distance 4r/135. So that point you must remember. I have drawn the different shapes of semicircles also, where the centroid is going to lie, and whatever the discussion I have done, so that you must have to remember. Similarly, when I drawn the quarter circle, I told you we'll have both x bar as well as y bar. X bar is equal to 4r/135, y bar also equal to 4r/135. I also told you these are all the derived equations. Okay, when I come to the derivation, at that time we will be able to know how we are getting y bar is equal to 4r/135. Whenever I discuss about even a quarter circle, how we are getting x bar is equal to 4r/135 and y bar equal to 3. When you derive the equation, at that time we will be able to understand. So now what is the chart I had given you. So next I discuss you about called as centroid of a flat plate. Okay, whatever the centroid of flat plate I have discussed. Okay, I have taken a flat plate in xy direction. Z axis is perpendicular. Okay, the total weight, as I discussed, the total weight of the plate exactly acting centroid. That point we mark it as G, and we have to locate the value of G, that is x bar parallel to x axis and y bar parallel to y axis. As I discussed, once again, as I am just summarizing what I have discussed so far. So now those points, why I am summarizing, you must have to remember correctly. Okay, so whatever the flat plate had taken now, so I told you the total weight of the plate exactly acting centroid, that is G. So applying the Verignon theorem, that is I told you moment of resultant is equal to sum of the moments of the individual forces about the same axis or the same point. So now what is the resultant? Resultant is total weight W exactly acting as the centroid. Okay, from centroid G we have to locate x bar as well as y bar. X bar is parallel to x axis, y bar is parallel to y axis. That x bar and y bar we have to get an equation. So that is why the same plate I divided into number of small parts, W1, W2, W3, W4. In the figure I shown W2, like that it is containing number of parts. So now if you add W1 plus W2 plus W3 plus W4 so on, you are going to get the total weight W. Okay, same weight W is divided into number of parts. So then I applied the Verignon theorem. How I applied the moment of resultant is equal to the sum of the moments of the individual forces about the same axis or same point. Now resultant is W. Perpendicular distance is x bar. So W into x bar is equal to small weight, individual forces. Small weight is W1, distance is perpendicular distance is x1. So W1 into x1 parallel to x axis plus W2 into x2 plus W3 into x3 plus W4 x4 so on. Okay. So then we got an equation x bar is equal to divided by W. So then the total weight when we write here in terms of density and area, volume. Okay. So after simplifying the equation, we are going to get an equation like this. That is x bar a1 x1 plus a2 x2 plus so on upon a1 plus a2. So similarly, y bar is equal to a1 y1 plus a2 y2 so on a1 plus a2. So these two equations, as I mentioned now, these are very, very important. Why? Because I told you when we start solving the problem, we require this equation. That is general equation for x bar, general equation for y bar. There, what are this A1? A1 is the areas of the individual elements. As I taken weight W1, that area is A1. Similarly, another weight, that is A2. Like that, this is area of the individual pieces. X1, X2 are the perpendicular distances from y-axis. Similarly, A1, A2 are the areas, Y1, Y2 are the perpendicular distances from the x-axis. So this point, whatever the points I have discussed, you must remember correctly, because when I come to the problems there, All those things you must have to remember, recollect correctly so that we cannot go on repeating same thing one thing, because when I come to the problem there, so this is a derived equation, directly I write the equation, then what is A1, I write the area, what is X1, Y values I write it. So then we go on doing step by step. After that, after deriving the equation, this one. Now next is what is called axis of symmetry. Okay. So how this axis of symmetry will play an important role concerned with centroid. I told you I have drawn three figures there, figure 1, figure 2 and figure 3. First figure, as I told you, if I draw a line exactly at the center, whatever the figure on the left side is same figure on the right side. Okay. So this is symmetrical about y-axis. This figure is not symmetrical about x-axis. Why? Because suppose if I draw a line here, wherever you draw a line, whatever figure on the top, same figure you are not getting at the bottom. Then means it is not symmetrical about x-axis, symmetrical about y-axis. Okay. Then what is the significance? I told you, first of all, you must have to detect where there is axis of symmetry. Centroid is going to lie on axis of symmetry. Okay. So that point I told you. So there is small derivation is not required. You must remember this. Centroid will not come here, will not come here. It is going to lie on axis of symmetry only. Similarly, when I come second figure there, okay, this is symmetrical about x-axis. Whatever the figure on the top, same figure getting at the bottom. It is not, if I draw a vertical line here, whatever the figure left side, same thing you are not getting on the right side. That means it is not symmetrical y-axis, symmetrical about x-axis. Whatever the figure on the top, same figure getting on the bottom. So this axis of symmetry, centroid is going to lie on axis of symmetry. I told you. What is the significance of axis of symmetry? You must have to locate whether it's symmetrical over x-axis or y-axis. Centroid is going to lie on that axis. When this figure symmetrical over x-axis, centroid is going to lie on this axis. Then third figure, I told you, if I draw a horizontal line, whatever is figure on the top, same figure at the bottom. If I draw a vertical line, whatever is figure on the left side, same figure on the right side. That means it is symmetrical about both x-axis as well as y-axis. At that time, where is the centroid? So wherever these two axes will meet, they are meeting at this point, x-axis and y. So this will be the centroid. Centroid either will not come here, not come here, not here, not here, but not here. It will come where these two axes are going to meet. So this is the significance of what is called the axis of symmetry. So these points, right from the point 1, what is the centroid, what is the center of gravity, all those points you must remember correctly. Once if you remember correctly, so then we can work out the further problems. Why? Because I told you, whatever the discussion I have done so far, okay, each and every point, right from the point 1, centroid, center of gravity, then whatever the standard figures I had given, and whatever the discussion I have done, all those things are very, very important, because if you remember them correctly, then I only go for the further problems. Otherwise, it is very, very difficult. Okay, whatever the discussion, because we cannot go on repeating. We cannot go on repeating whatever the discussion already repeated 2-3 times in the class. I will repeat what are the important points. So those points you must remember and go through what I have done in the class. Once you go through that, you will be able to understand clearly what I have done there. Then when I come to the problems there, whatever the discussion I have done so far, what is the equation for x bar, what is the equation for y bar, what are the center of gravity of the standard plane figures, what is the significance of axis of symmetry, all those things will play a very, very, very important role. So then we stop here. Further things when I come to the problem there, further things we discuss in the next class. But when you come to the next class, whatever the discussion I have done, you must come revised. We cannot go on repeating what has been done in the previous class, because we cannot waste the time. Okay, so what has been done now, I have already repeated 2-3 times to make it clear. What you must do, go through that, read it 2-3 times, come prepared, so that when I come to the next class, directly I can start problems. We cannot go on repeating what I have done. Okay, tomorrow we meet.